hello everyone. Good evening. How are you all? Good evening. Hope you all are good and best of your health, right? Guys, we'll start our session within 2 to 3 minutes, 40 or 2 minutes, a short time. Okay. Before that, yes, actually, I would like to tell you one point here. Already we completed the atoms, right? Atom and modern physics may dual nature of matter, atoms, nuclei, and semiconductor. These are the three main chapters which will become. Among that, atoms is completed. And today we are going to discuss and we are going to solve few good numericals which are asked in previous year JEE exam. Okay, the today's target is all about previous year JEE questions. Clear enough? Right. Am I audible, right? Let me check through the YouTube once. Yes. I'm audible properly. That's a great thing. Yes, good. Today's topic, already I told you that previous year numerical questions. Before going to numerical question, let us take a quick recall, or else we can list out the formulas which we needed to solve this chapter problems. Okay, basically we started with the Rutherford experiment. I think you remember this one, right? Okay, Rutherford experiment में दो equation सब मिला था हमको, right? That is a force, right? Actually, electrical force which will be given by here Z E square divided by 2Z E square divided by 4 pi epsilon naught R naught square. Right now, this is the first equation we got, and second one impact parameter मिला था. Correct now, impact parameter. Remember, impact parameter means velocity of the first trajectory of the electron to the central trajectory of the electron or alpha particle. Correct now, that is what we got there. Z E square cot theta by 2 divided by tell me kinetic energy, right? In denominator 4 pi epsilon naught, don't forget to put here. Okay, and then later on we discussed about the impact parameter हो गया था, distance of closest approach we discussed. Correct ना? That is the value of R naught, right? R naught value कैसे लिखते हैं आप? It is actually we derived from centripetal force and as well as the electrical force. Correct? Centripetal force होता है mv square by r. Electrical force होता है z e square divided by 4 pi epsilon naught into r square. Here we took r naught this one. करेक्ट ना? 1r कैंसल हो गया था. r naught को इधर लेने से क्या होता है? इक्वेशन z e square divided by 4 pi epsilon naught m v square. Right? This is what we got, an equation for r naught. Right? This is what Rutherford theory. After failing of Rutherford theory, who came? Bohr. Correct now? Bohr given 3 postulates. Correct now? In his first postulate, what he told? Atom means it's a center part of the atom. We call that one as a nucleus. Correct now? Inside the nucleus, proton and neutrons are there. An electron which is always revolving around the nucleus, right? With a fixed distance, or we call this one as a radius. And when it is revolving in certain orbit means ये ऑर्बिट के लिए एक एनर्जी होता है. करेक्ट ना? एनर्जी ऑफ द orbit. ये दोनों equation first both postulate given, correct ना? Radius of the orbit comes to be n square h square epsilon divided by pi m e square. In here you can multiply with z also, correct ना? This is the radius equation we got. And kinetic energy value. Energy value we got our around minus m e to the power of 4 divided by 8 pi, sorry, 8 epsilon naught square n square h square. Right? This is the equation for energy. Here another n value is constant, sorry, changing, and remaining all are constant. Here also r value is proportional to n square. Here energy value is inversely proportional to the value of n square. N stands for, guys, principal quantum number. N stands for principal quantum number. Clear है ना ये बात? Correct? If I did any mistake, please let me know. These are the equations. Later on, next. Okay. Next. Okay. With a fixed distance radius में fixed energy state n is equal to 1 में एक इलेक्ट्रॉन is revolving, करेक्ट ना? इसके पास एक angular momentum होता है, right? The angular momentum of an electron which is revolving in a certain orbit is given by n is equal to integral multiple of h by 2 pi. This value will be changes from state of the electron which is revolving. In a ground state which is revolving means n value will be 1. In a, here two states are there. That's why second state we will call this one as an excited state. Here the value will be changed. The n value will become 2. Correct now? Okay, if in case electron from the excited state to ground state, it will be jump मारता है. क्या होता है? It releases an energy, that is h nu. Here the along with the frequency it has a wavelength. Correct now? To calculate that wavelength, we got an equation 1 by lambda is equal to r into 1 by n1 square minus 1 by n2 का square. Clear है ना? सारी देखो एक बार. Check it out once. And frequency also we calculated, right? Frequency के लिए equation क्या होता है? Frequency के लिए m e to the power of 4 divided by 8 epsilon naught square epsilon. Yes, 8 epsilon naught square h cube into 1 by n1 square minus 1 by n2 square. Right? Based on the energy from which state to which state it will be jumped. No, based on that numbers, it will be varying frequency. N value can inversely proportional here. Correct? This is frequency, and we call, okay, and then after we talk about the wave number also, right? Actually, frequency means c by lambda, correct now? Here it will become n e to the power of 4 divided by 8 epsilon naught square h cube into 1 by n1 square minus 1 by n2 square. And then lambda you want means take c to right hand side. Then 1 by lambda is equal to m e to the power of 4 divided by 8 epsilon naught square h cube. Correct है ना? Right. 1 by n1 square minus 1 by n2 square. Right? This is the equation for wavelength. And also we told that 1 by lambda value will be equal to the wave number. Wave number कैसे represent करता है? Mu frequency के ऊपर एक bar लगा दो. This is the wave number. Bar means not that bar. This is a bar. Short line. है ना? Frequency is equal to m e to the power of 4 divided by 8 epsilon naught square h cube into 1 over n1 square minus 1 over n2 square, and this whole quantity we called Rydberg constant R. Correct ना? इसका value होता है 1.0967 into 10 to the power of 7 per meter. Clear? Hope it is all required. And last but not the least, last but not the least, uh, which one? Actually, yes. An electron which is revolving around this nucleus means, Manlo, it's the center part of the nucleus. An electron which is revolving around this nucleus means it possesses angular momentum nh by 2 pi. nh by 2 pi. During in this condition, I, actually this is the equation Bohr given. Actually, it is proved by the de Broglie. Correct now? De Broglie. According to de Broglie, we know that if any matter which has a mass which is moving with some velocity v means, right, along with this matter there is an wave will be associated. This is what the de Broglie equation gives. According to this, electron which is moving means along the electron in an orbit there is a wave also moving like this. मेरा ड्राइंग तो खराब हो गया, थोड़ा एडजस्ट कर लो. Right, like this wave is associated with the electron. Right, here the distance covered by the electron is equal to n lambda. This is what the condition he took. Right, this is what the condition he took, and he satisfied the equation L is equal to n h divided by 2 pi. Clear now? These are all the formula list which are came under the chapter orphans. Clear? Let me know through the chat box if you have any doubt means. Meanwhile, if you have any doubt means, please drop your doubt in the chat box quickly. Hope it is understood, right? चलो चलते हैं आज के क्लास के ऊपर. आज के क्लास का पहले क्वेश्चन. Already I told you today we are discussing only the problems. Correct ना? Okay, first problem क्या है? क्या हो रहा है? हाँ. Graph in which dissipates the result of Rutherford gold foil experiment with the alpha particle is alpha is scattering angle, n is number of scattered particle is detected, and plots schematic and not to scale. Okay, here we need to find out the correct graph for the number of alpha particles scattered in Rutherford experiment. How the number of particles varies with respect to the angle. We need to calculate it. Okay, let me know which is the correct answer for this question. Easy है, बहुत easy है. जल्दी से बता दो. I told that if you consider this the gold foil, right? Alpha particles, it is nothing but helium 24. They are rushing towards the gold foil. Maximum percentage without making any deflection, they will be move straight like this. Okay, and in a little way, few of the only very 8,000 alpha particle they are reflect back. Means around about 90 reflect back. Now, this is actually said by here. Dekho, B value hai. B is the no. This is the correct answer. Actually, this graph I explained in a class also, right? When angle is there is no angle, the number of beta particle is maximum. When it's 90 degree, the scattering of alpha particles, the gold foil also decrease continuously. The correct answer is. Actually, we discussed this one in a class, right? Good numerical. Next question. The question says here, this is the easiest question, guys. The diagram shows the depth, diagram shows the path of the alpha particle of the same energy being scattered by nucleus of an atom simultaneously. Which one of these are or is not physically possible? Means a diagram में आपको schematic diagram में some data they given, correct ना? Consider this is a positive nucleus. These 1, 2, 3, 4 are there, no? They are the alpha particles. When alpha particles are start to rush towards the nucleus, okay, which one of these four physically not possible? We need to identify this. Which is not possible among the four? Actually, alpha particle means this is also positive charged body particle. Correct now? This is a nucleus. When positive particles are moving closer, okay. If it is moving in this position means without being deflected, it will be moved without deflection. As the impact parameter distance decreases towards the nucleus, the positive charge and positive charge electrostatic force of repulsion will be started. Correct now? Due to first alpha particle, it will come when the positive charge will be repel the alpha particle. No, being in a position means in a regular path, it makes an angle theta and it will be also scattered more angle than the first, and it is also moving up. Coming to the third is also very closer. That's why it is make an angle very large. And fourth alpha particle actually bending towards the positive. It is actually not possible. Being in positive charge, how it will be attracting towards the nucleus? And for this question will be 4. Correct now? Fourth alpha particle, which is not actually physically not relation which will be given in the diagram, right? It is not a correct answer. These are all the correct answer. Okay, don't get confused here. Okay, for this question, correct answer is option B. Clear enough? Good. Coming to the next question. अब बनता है questions. Okay. Oh. Okay. Question is that here the first 3 spectral lines of a hydrogen atom. First 3 spectral lines of a hydrogen atom in a Balmer series. No doubt. Which series is this one? Balmer series are given lambda 1, lambda 2, lambda 3. Considering the Bohr atomic model. Bohr atomic model में spectral lines they given. Okay, first 3 spectral lines for the hydrogen atom. Okay, and the wavelength of the first and third spectral lines. We need to calculate the wavelength of the first and third spectral lines in the ratio, wavelength ratio are related to the by a factor approximately x into 10 to the power of -1. Okay, we need to calculate the value of wavelength and we need to keep that one in the ratio of 10 to the power of -1. In this value, we need to keep the value of x to the nearest integer is. What is the value of x they are asking? Integer type question, guys. This is actually 2021 ka JEE paper question. Okay, they are asking about Balmer series, not line. Correct now? Balmer series, you know, right? This is a ground state, first energy state, second, third, fourth, fifth, like this. N is equal to 1, 2, 3, 4, 5, 6. Guys, let me know if Balmer series we need to take means what is the ground state for the electron, which is jumping from higher energy state. This is the ground state. Obviously, N1 value will be 2 and N2 value will be 3, 4, 5, 6, like that up to infinity. Correct now? Now 2 is the ground state. First member of the electron which is jumping from third state to second state electron. It is exhibits some wavelength. We call this one as a lambda 1. Correct now? And they're asking the third. Correct now? First हो गया. देखो इधर wavelength of the first and as well as the किधर third spectrum. 4 to 3 ये नहीं चाहिए. थर्ड वन होता है 5 to 2 ये हमको चाहिए. This is the lambda 2. These two, okay, this is lambda 2, this is lambda 3. Correct now? These two ratios we need to find out and we need to put the integer value. I hope you got an idea how to calculate this. Correct now? Simple है यार. Lambda calculate करने के लिए equation क्या है? 1 by lambda 1 is equal to Rydberg constant into 1 over n1 square minus 1 over n2 square. Lambda 1 है ना? Okay, 1 by lambda 1 is equal to r into 1 by n1 square means n1 का value 2 है. Spectral series. Okay, 1 by 2 square means 4 minus 1 by n2 square. N2 means first spectral line which is coming from the third existing. Means 9. 3 square will be 9. Correct now? It will come 9 4 6. 9 minus 4 means 5 into r. Correct? This is what the value of lambda 1. R at 1 by lambda 1. Lambda 1 value will become 36 upon 5r. Okay, na? Right? Good. And coming to the next, lambda 2. We don't want lambda 2. Okay. We are comparing that one with the third spectral one. That's why directly you take third one. Lambda 3 is equal to r into n1 value 4 because it's a ground state. Correct now? And n2 value which is coming from actually fifth energy state. देखो fifth energy state से आ रहा है. Third member of the Balmer series. Correct now? 5 square means it is nothing but 25. Right? 25 into 4 it is nothing but 100. 25 minus 1 means 25 minus 4 means 21 into r. This is lambda 1 by lambda 3. Lambda 3 value will become 100 upon 21 r. Correct now? Right? Now we need to calculate the values. Lambda 1 by lambda 3. First one 36 by 5 r. Second one 100 by 21 r. I'm going to calculate that one on the same page. There is no space. Okay. I will calculate this one here. ध्यान से देखो. Lambda 1 by lambda 3 is equal to lambda 1 value कितना है? 36 divided by 5 times r into here lambda 3 is nothing but 100 over 21 r. Correct ना? r से r cancel हो गया. Hence lambda 1 by lambda 3. Guys, I already calculated this one. This value will become across 1.51. Okay, this is what the integer value we need. Actually, what they are asking. Simple enough, but you need to be very clear about the member of the spectral series. Okay, it is coming from it's a Balmer series. They might be asked to ask the same thing for the hash and bracket. Okay, members also different way from where the electron which is coming. Clear enough? Let me know through the chat box. Is it understood right? Quickly say yes. If it is understood, means please let me know in the chat box. Is like that. Okay. Good. Then we'll move to the next question. Correct now? Okay. Question is says like that here. The recoil speed of the hydrogen atom after emits a photon is going n is equal to 5th state to n is equal to first state. कैसे कैलकुलेट करते हैं? Recoil speed they are asking. Recoil. Did you heard this sound recoil previously anyway? Recoil. What is the meaning of recoil? Hmm? Yes. In conservation of momentum. Newton second law. In Newton second law, actually it came. Correct now? Recoil speed. Right? Based on that one only we need to calculate this one. But here the thing is that electron actually jump from fifth energy value will be fifth state to first state, they are saying. Hi Davangere team. How are you all? After a long time. Okay. Energy will electron will come from high energy state to lower energy state with the emission of photon in the form of energy. Correct now? H nu. Correct now? Now, here I told that conservation based on the conservation of momentum we need to solve. Okay, now conservation of momentum क्या बोलता है? Actually, initial momentum value will be equal to final momentum. This is what the statement of the conservation of momentum. Momentum means P. Correct now? You know, right? Momentum value P is equal to M. This is what the momentum. Initial momentum. Okay. Initial momentum means when it is moving upward or downward. Mass into velocity. Mass into velocity. Correct now? Final momentum क्या होता है? Actually, when it is moving from higher frequency energy emit करके आता है. ಹಾಗಾಗಿ now while writing the final momentum we need to take this one in terms of de Broglie wavelength. इधर de Broglie wavelength utilize करके लेना है. Okay, according to de Broglie wavelength, lambda is equal to h by p. P value will become now h by lambda. Hence final momentum क्या होता है? h by lambda. Correct now? Call equation number 1. Call equation number 1. Clear है ना अब तक? If you have any doubt means up to this point, let me know through the chat box. Clear? Next, actually हमको velocity नहीं मिल गया. Correct ना? Actually the velocity calculate करने के लिए mass भी होना चाहिए, de Broglie wavelength तो चाहिए हमको. Correct ना? We don't know the wavelength, but we can calculate the energy. No, energy तो आसान से calculate करते हैं. Correct? How to calculate the energy? मान लो दिस ग्राउंड स्टेट मीन्स इसका एनर्जी होता है -13.6 और 13.54 इलेक्ट्रॉन वोल्ट. करेक्ट ना? एनर्जी ऑफ द फिफ्थ मीन्स इट विल बी 0.54. I think it's 6. Yes, this is 6. 13.6. फर्स्ट स्टेट का एनर्जी कितना होता है? N1 value, energy value will be here -13.6 electron. Correct now? By utilizing the energy, we can solve this problem. How? I will explain you soon. Energy होता है h into nu. Correct ना? h into nu. Here energy will be released just due to the electron will be jump from higher energy state to lower energy state. Means we can say this one as an delta E is equal to h. Here nu means it is nothing but T by lambda. Clear है ना? ये delta E is nothing but E2 minus E1 is equal to h by lambda into c. h by lambda into c. From equation number 1, देखो इधर h by lambda value is nothing but m into p, m into v. Here E2 means it is nothing but minus 0.54 minus into minus plus. E1 means it is nothing but 13.6 is equal to h by lambda है ना? ये equation को इधर रखो. Right? Then it will become m into v into c. क्लियर? देखो बहुत आसान है ये प्रॉब्लम. ओके, देन this two summation will give around 13.2 electron volt, right? 13.1 second, 13.06, oh, 13.06 this one, m into v into c. Clear है ना? Okay, then after again we require, that is the recoiling velocity. Take m into c to left hand side, then it will become 13.06 divided by mass into speed of light, right? It will give the velocity, recoiling velocity. Here 13.6 electron 6 है ना, this is in the energy in the form of electron volt. You need to convert this one to joule. joule को convert करना है, right? joule को convert करना है means, yes, देखो इधर I will come continue this one in the next page. इधर क्या हुआ था? Yes, this is a 13.06 divided by m into c. Correct ना? I will continue this one on next page. देखो इधर 13.06, this is an electron volt. Convert this one to joule means 1.6 into 10 to the power of minus 19 को multiply करो, joule हो गया. Because velocity in meter per second, देखो इधर ऑप्शन तो मीटर पर सेकंड में है ना, that's why. Mass means mass of an electron 9.1 into 10 to the power of minus 31 into speed of light 3 into 10 to the power of minus, sorry, plus 8. No, एक मिनट और एक थोड़ा मिस्टेक हो गया. क्या है ना, इधर मास, मास ठीक है ना, करेक्ट है, ओके, करेक्ट 9.1 into 10 to the power of minus 30. Okay, calculate this one completely. Calculate करो, आपको a recoiling velocity है ना, this recoiling velocity will be obtained around 4.71 meter per second. Option number E. Okay, try to calculate this. Actually formula directly नहीं मिलता, correct ना? The given recoiling of a gun means you need to think like that, it's a conservation of energy. Energy होता है, from energy we can replace something here, correct ना? In this way only you can calculate. Hope it is understood. Chat box में बता दो. Okay, cool. Then it's fine. We'll move toward next problem. Yeah. Problem तो नहीं है, थोड़ा पढ़ना है. Okay, in the given figure, energy levels of a hydrogen atom have been shown along with some transition marked in A, B, C, D, E. Okay, the transition of A, B, C are respectively represents. Okay, we need to say that here transition they given, transition of electron from certain energy state to ground state, that state it will become. Okay, based on the transition, we need to represent that it is okay. Suppose okay, from state to state it become, actually continues. It is from infinity. From infinity to ground state is coming means what is the value of this one? Is how we are going to say this one, whether it is a first member, second member, or it is a series limit. Series limit means last line of a spectral series. It is known as a series limit. Okay, like that we need to identify. Okay, which is the correct answer? Let me know. पढ़ लो थोड़ा. I will give you 1 minute after. Yes, correct answer. Right. Option C is the correct answer. How? Actually, first they given ionization potential of a hydrogen atom. Second member Balmer से ionization potential नहीं होता है इधर. Ionization potential means we need to remove the electron from the outermost electron shell. Ionization means it won't come in this question. Answer will not come. Leave it. Second question क्या था? First member of the Lyman series. ये they are saying in series A, B and C we need to explain. First they are saying first member of the Lyman series. Lyman series में first member कहाँ से होता है? N2 to N1 होता है. This is the first series. Correct ना? Then from this point itself, the second statement is wrong. Correct now? Coming to third one. The series limit of a Lyman series. Series limit means last line. Correct now? The energy will be emitted from the last line of means infinity to ground state. When the electron will be jumped from infinity to ground state, that one will take a series limit. Correct now? Hence it is correct. Okay. A is correct. I will mark it. Okay, good. Then B. B, what they said? Third member of a Balmer series. Third member means क्या होता है? Balmer series में देखो n is equal to 1, 2, 3, 4, 5. Lyman is the first series. Balmer is the second series. In second series, Balmer series के लिए first member है 3 to 2, second member है 4 to 2, third member है 5 to 2. Check whether it is correct or not. देखो इधर 5 से 2 तक आ रहा है. Yes, it's the third member of a Lyman series. Correct answer. Hence, this is the correct. And C, second member of the Passion series. Passion में क्या होता है? Passion is the ground state is nothing but 3. Correct now? Okay, ground state is 3. Actually, it is coming from 5. You are saying second member. Okay, first member to 4 to 3. Second member to 5 to 2, 5 to 3. Yes, obviously. Hence, the correct answer obtained to be option C. Option C is our correct answer. Congratulations, guys. Well done. This is a JEE question. Previous year का. कितना आसान है ना? आपको भी ऐसा पेपर आने वाला है. हिम्मत रखो. Okay. Be confident. Physics is not a difficult subject. Okay. Okay, next question. Next question, guys. According to the Bohr atomic model, in which of the following transition will the frequency is maximum? Maximum frequency where you will get when electron jump from higher energy state to lower energy state. I need answer within 1 minute. Okay, just in 1 minute. मिल गया क्या आंसर? अरे यार इतना इजी है. ओ करंट गॉन. देखो इधर डेविल है. Right? Okay, no problem. We'll move. Yes, according to Bohr model, which of the following transition will be the maximum frequency? Actually, guys, frequency means क्या होता है? It is nothing but energy. E is equal to h nu. E value is directly proportional to frequency means frequency is nothing but energy. I told you in the real nature of matter. Correct now? Here, okay, देखो इधर. This is a 1, second state, third, n is equal to 4. Okay, man, no. Lines are not proper. Try to understand this one. I know ground state has a 13.6 electron volt. Second one minus 3.4 electron volt. Fourth one 1.54 electron volt. And fifth one 0.54 electron volt. Correct now? देखो इधर. If the electron will be jump from second state to first state means the energy will be released around 10.02 electron volt. if the electron will jump from third energy state to फर्स्ट एनर्जी स्टेट मींस इसका वैल्यू कितना होता है देखो इधर दे डिडंट यू नो फोर्थ एनर्जी स्टेट टू थर्ड गिवन ओके ओके दिस इज नॉट देयर ओके फर्स्ट वन ओके सेकंड वन फोर्थ टू थर्ड second one 4 to third 1.54 0.54 small value and then third one n5 to n4 that is also one small transition it's also having small energy value n3 to n2 n3 to n2 this is also small one okay but देखो इधर 13.6 to 3.4 in this energy level से electron will jump means around 10 electron मिलता है 10 electron volt मिलता है this is the maximum amount of energy which will be gained by the sorry which will be given by the electron means answer A is correct ठीक है ना right right good we'll move to the next question or a question yes it is there I will give you one homework question answer today okay yes here the question is this is the super duper question for this session okay the particle of mass देखो इधर mass they given 200 ये क्या हो रहा है मेरे लैपटॉप से 200 mega electron volt per c square here c is nothing but speed of light collides with a hydrogen atom this is a particle I don't know this is a hydrogen atom it is actually at rest now this particle come and collide this particle hydrogen atom soon after the collision the particle comes to rest now this particle will comes to rest and the atom recoil and goes to its first excited state means hydrogen atom क्या करता है actually ionize हो गया है ना ground state पे now it will be comes to excited state next slide okay the initial kinetic energy of the particle is in electron volt that is n/4 बहुत अच्छा है क्वेश्चन देखो kinetic energy value initial kinetic energy value n/4 है okay now we need to calculate the value of this n का value पता करना है this is the question and they given a mass of a hydrogen atom take as an 1 giga electron volt per c square okay mass of hydrogen atom कितना दे given 1 giga electron volt per c square and mass of a particle I don't know this particle will be 200 mega electron volt per c square okay right once along with me here it is simply given like that I will explain how it will become also particle of mass m they took here hydrogen particle of mass 5m how it will become no देखो I will explain this one again we need to apply here conservation of momentum simple mass of hydrogen is equal to 1 giga means 10 to the power of 9 electron volt per c square guys mass means kg how we are going to write like this don't get confused with this one actually हमको पता है kinetic energy value our energy value is equal to mc square m value is nothing but mass take c square to left hand side then it will become energy by c square is equal to mass को a unit में लगता है kg only there is nothing change okay here electron energy they given in terms of electron volt c as a c square that's it okay coming to here mass of hydrogen by mass of that particle कितना था 200 into 10 to the power of mega electron no 6 electron volt per c square this electron volt per c square this electron volt per c square cancel हो गया इधर mass of an hydrogen is equal to देखो इधर 6 में 6 कैंसिल मींस ये 3 बचा 2 से 2 कैंसिल एक ही बचा correct ना right what I'm saying then after calculating this one 1 by 10 by 2 nothing but 5 times the mass of a proton. Means हाइड्रोजन का मास कितना है 5 times the mass of that particle. That's why here they took कंजर्वेशन एक्सप्लेन करने के लिए देखो इधर पार्टिकल ऑफ मास m मींस हाइड्रोजन एटम का मास कितना है 5 टाइम्स आफ्टर द कोलिजन फर्स्ट ए रेस्ट में था आफ्टर दिस कोलाइडिंग पार्टिकल विल बिकम रेस्ट and this hydrogen atom gains to the first energy state. देखो first excited state into को जा गए right now with some acquiring some velocity. We don't know this velocity, we need to find out this and kinetic energy they given correct na. Okay, finally we need to calculate the value of kinetic energy. Change in kinetic energy calculate करने से हम आंसर मिलता है हमको. कैसे कैलकुलेट करना है देखो इधर change in kinetic energy value will be kinetic energy of initial final minus kinetic energy of initial kinetic energy तो पता है कोई प्रॉब्लम नहीं करेक्ट ना. kinetic energy को एक्सप्रेशन देखो 1/2 m v square initial velocity of that particle minus second one of m कितना होता है second one 5 times the m velocity of the hydrogen atom we need to calculate. पार्टिकल तो पता है वेलोसिटी कोई प्रॉब्लम नहीं v वेलोसिटी से मूव हो गया इधर करेक्ट ना. इसका वेलोसिटी फाइंड आउट करना है. देखो कैसे कैलकुलेट करना है और एक बार बोलता हूँ कंजर्वेशन ऑफ मोमेंटम बेस्ड ऑन दी कंजर्वेशन ऑफ मोमेंटम. क्या होता है इनिशियल मोमेंटम इज इक्वल टू फाइनल मोमेंटम. इनिशियल मोमेंटम क्या था दोनों पार्टिकल के लिए m into v था फॉर द पार्टिकल. सेकेंड वन 5m into v कितना होता है v of hydrogen atom. It is actually at rest, hence it will become 0 initially. After the collision, mass into velocity of the particle will be 0. That's why this one will become 0 plus final momentum is mass of a hydrogen atom 5 times the m into vh. Correct now both the side m cancel हो गया. Here vh we want right now. Then take to 5. Then it will become guys here I will write it is nothing but vp divided by 5 is equal to vh. Correct now means hydrogen atom का velocity it is 1/5 times of the particle velocity. मिल गया ना. Now substitute this equation in this equation number 1 kinetic energy change in kinetic energy value. In the next slide I am going to continue this one. Okay, be here. Change in kinetic energy कितना होता है देखो इधर change in kinetic energy will be equal to किधर बन गया यार. Okay, half m vp square minus half 5 times the m v का वैल्यू कितना हो गया vp डिवाइडेड बाय 5 हाइड्रोजन एटम का स्क्वायर राइट ना. एंड देन ये दोनों इक्वेशन में 1/2 we can take common, m also we can take common and vp square also we can take common. Correct now. Remaining thing here in this equation 1 minus here 5. okay just a minute. इधर देखो vp कॉमन लेने से vp स्क्वायर 1/5 स्क्वायर था न्यूमरेटर में 5 स्क्वायर मींस इट इज नथिंग बट 25. 5 1 जा 5 5 जा then it will become 1/2 m vp square into here 1 minus 1/5 again 1/2 m vp square into 5 minus 1 4/5 हो गया. करेक्ट ना. देखो इधर कि half m vp square is there. No, this is actually kinetic energy. Kinetic energy value is equal to 4/5 हो गया. Actually this change in kinetic energy when it is jump to higher energy state at that momentum they given the value of kinetic energy. Correct ना. wait करो load और पीछे slide I will show that one. yes here देखो किधर 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 कहाँ गायब हो गया है. हाँ kinetic energy of the particle इधर लास्ट लाइन में देखो ध्यान से सुनो the kinetic energy of the particle is n by 4 time. Means now we need to substitute this change in kinetic energy value as an n by 4. Okay, substitute this value here. Dekho. Change in kinetic energy will be equal to kinetic energy into 4 by 5. Change in kinetic energy is nothing but n by 4 is equal to here 4 by 5 times of the kinetic energy. क्या हो गया? नहीं मिल रहा है ना? कुछ तो गड़बड़ है ना? Yes, sorry. One more step. Here second state गया है. Second state गया means what is the energy? Change in energy कितना आता है for the second state? 10.06 होता है. Sorry, 10.02 होता है electron volt. Correct ना? Is equal to kinetic energy 4 by 5. Right? Now you take this one to right left hand side. Then 5 into 10.02 divided by 4 is equal to kinetic energy. Oh my god. आ गया. Finally the kinetic energy value will be n by 4 the given. Correct? Here कितना होता है? 5 into 10.02 divided by 4. Correct now? Right? Cross multiply this one and you will get the answer. N value will be nearly equal to 51. ये 4 से 4 मर गया. 10.02 into 5 almost all 51 होता है. Correct ना? This is the integer number. Clear? थोड़ा lengthy था, but this is a good question which is asked in a previous year meet. Sorry, JEE. Okay, and moreover, this is a question which I am going to give to all of you as an homework. This is the homework question. Okay, try to do this one in our home, and in our tomorrow class I will continue this one. Okay, thank you everyone for attending here. Okay, we'll meet in our tomorrow class. Okay, if you have any doubt, means please be staying in the call, or else you can do the class. That's it for today's guys. That's it.